Hello everyone, it's Alexi here from AstroArt, and today we are going into the world of cooled, dedicated astronomy cameras. Astrophotography is a gateway to the stars that anyone can walk through. With today's technology, especially cooled CMOS cameras, capturing beautiful images of space is breathtaking and fun. The difference between DSLR and cooled, dedicated astronomy camera is big. In this video, I'll walk you through the essentials of using cooled CMOS cameras, which are crucial for high-quality astrophotography. Stay tuned to see some stellar images captured with this tech. I made the transition to the cooled cameras last year, and I could not be happier. Images are insane quality and easy to process. Let's dive into the world of cooled CMOS cameras, which are specifically designed to enhance your astrophotography experience and take high-quality images of space. Cooled CMOS cameras are equipped with temperature regulation to reduce noise, providing cleaner and more detailed images of the night sky. The most important thing is that the temperature remains constant. With non-cooled cameras, every time you start the exposure, the temperature will start to rise and it will be impossible to calibrate the images correctly. With cooling, the noise gets lower and you are left with cleaner images. Added bonus of cooling is that even in summer season you are able to enjoy reduced noise on your images. We can see up to 50 degrees Celsius on DSLR sensor compared to up to -20 at summertime on cooled CMOS cameras. 70 degrees Celsius is huge difference in noise levels. Notice the cooling vents and the heatsink. These components are vital for the cooling system that ensures optimal performance during a long exposure. There is a Peltier element inside the camera that cools the other side and warms the other side. The cold temperature is directed with cooling pads to the sensor. Interesting fact, there was an oil leak problem on the 2600. The thermal pads used in this environment was the cause of the problem. It's fixed a long time ago, but still if you get oil streaks on your sensor, it's good to change the pads. We example do that in AstroArt. You might not know, but we have ZWO and TopTech service centers for all Scandinavian customers here in Finland. Sensor or fan change is no problem to us. Also, one of the major differences between a DSLR and cooled dedicated astronomy cameras are the filters inside. DSLR is optimized for daytime photography. In daytime photography, we want to see the colors that human eye can see clearly. But in the sky, we want to see the deep reds of nebulae. Cooled astronomy cameras will let the whole spectrum to the sensor without blocking anything. Cooled astronomy cameras can be up to 80% more efficient compared to unmodified DSLR. I'll do my best to explain the exposure time, gain, and cooling level for deep sky imaging with a cooled CMOS camera. Let's keep in mind that there is no one correct answer for any of these. This is a complicated topic and it's good to understand the basics. There is no one ultimate camera settings that will work for every scenario. Everything depends on your sky conditions, gear, target, etc. When you understand the basics of the camera settings and roughly know what works for you, then you can fine-tune and see what works the best for you. Let's first talk about the exposure time. The basic idea is that you swamp the read noise of the camera with the actual signal. This is swamped easily on the bright targets, but when you also want the background to be noise-free, you need to check that there is enough signal coming to the background also. Fun fact is that the more you have light pollution, the less exposure time you need. When you are at dark sky side, you need to use longer exposures to get rid of that nasty noise. But don't get mixed signals here. Darker skies are always better. Gain can be thought as ISO of cooled astronomy cameras. It has significant impact on your final image. Gain rules how much one photon will count as electrons in the pixels. This is complicated, but you can think the pixels as a well. You want the well to have enough water to measure the level, but you don't want it to overflow so you can get accurate measurement. The gain adjusts the well's depth. When you set your gain and exposure time correctly, you can cover the dirt on the bottom of the well. Dirt means the noise. Water is the signal you want to measure. You get good, accurate reading of the water level when it's not empty and not too full. This helps you with the dynamic range of your images too and lets you stretch the image more. Cooling is set so that the camera can keep the same temperature fixed. You also want to use a temperature that lets you use 1 or 2 sets of darks to the whole summer. You don't want to blast the camera with 100% power of cooling and the other hand not to cool at all. When you can use the cooling on 50%, you have maximum room on both sides. Let's say that you image in plus 10 degrees Celsius conditions in the autumn and minus 10 in the winter. Then personally I would set the cooling to minus 15. This means that in spring and autumn you will need to use the camera at 60% cooling, and in the winter you can use it around 20 to 30%. It all comes down to the local temperatures you have in there. In Finland it is complicated as we can have plus 20 in the autumn and minus 30 at winter. So we usually use like minus 10 and minus 25 at our cameras to cover the whole year. Mounting your cooled CMOS camera to a telescope is straightforward. You put together your spacers which came with your camera and screw it to your telescope. Once it's mounted, then it's time to connect your camera to a capture device, ASI Air or laptop for example. Most modern CMOS cameras use USB 3.0 connectivity for easy data transfer and camera control. That's all for today. I hope this video cleared features and settings of cooled CMOS cameras. Check the description for links to the gear and don't forget to like and subscribe and tell us what other astrophotography topics you are interested in. And now I will show you an image taken with DSLR versus dedicated astronomy camera.